Hey kids, Flexing Teacher Weber here. I hope you're having a good day. We have finished our work with fractions and now we're going to move into a unit on integers. Specifically, we're going to start off with adding and subtracting integers, which is something you would have done in grade 7. So we'll do a quick review of that and then we'll move into multiply and divide integers, and then we'll use integers in order of operations all together, and we'll even explore some exponents and things like that. But first we'll start out with what you already know or should have already have some idea about, and that's adding and subtracting integers. Now I just want to start off with a little review of what integers are by doing a little word problem. This says, in the morning the temperature was -4 degrees Celsius. By noon the temperature dropped 6 degrees. What was the temperature at noon? We're going to solve this on a number line because the best way to look at integers is to look at them on a number line. So integers include all positive and negative whole numbers and 0. So let's start this number line off with 0. So I'll put 0 here, and then I'll put +1, +2, +3, +4, and I could go on and on and on and on and on and on forever. And as I go on in this direction forever, the integers get larger. But my page doesn't go that far. And then to the left of 0, I have the negatives. And as you go this way, you get smaller. -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11. And you could go on and on and on and on and on and on this way, and the integers would keep getting smaller and smaller. So as you go in the negative direction, integers get super small. As you go in the positive direction, integers get larger. Now, this problem, it says in the morning the temperature was -4 degrees Celsius. So let's say this is where it started. We'll call this morning. Okay. By noon, the temperature dropped 6 degrees. Dropped means it got colder. So we have to drop 6 degrees or get colder 6 degrees. I'm going to skip count backwards on the number line. 1, 2, 3, 4, 5, 6. So by 12 o'clock noon, the temperature was -10 degrees Celsius. It was getting colder. How could we look at this same question as a integer statement? Well, we could say we started off with -4 and the temperature dropped 6 degrees. So it ended up at -10. Now, another way we could write that, we could say -4 combined with or plus -6 equals -10. These are the kinds of integer statements we're going to be looking at over the next couple of days. To look at those kind of integer statements, we're going to have a model for integers. I'm going to flip forward. Last year, or maybe last year, we learned that the sign in front of an integer belongs to the integer and determines its sign. So for example, if there's a positive sign in front of the integer, then it's positive. It's a +4 or +4. And if there's no sign in front of the integer, then that still means it's positive. Now, if there's a minus sign in front of the integer, that means negative. So this means -4. We also have a model we use for demonstrating what integers look like with pictures. Often we use red circles, or if we actually have them in class, we use something called integer discs to represent integers. Now, a lot of textbooks use a red integer disc for positive, but I like to use a black integer disc because if I get you to draw them out, it's really easy to draw a shaded in integer disc, but you might not always have like a red marker or a red pencil crayon. Now, negatives are often shown in textbooks with a blue integer disc. I like to use a clear, unshaded integer disc because that way you have a very clear distinction between positive and negative. So I like to say the positives are black and the negatives are shaded, unshaded. And it's very easy to tell the positives and the negatives apart. Now, the most important thing about this integer model is that a positive and a negative cancel each other out. So if you have a situation like this, I'm just going to draw a couple integer disks here. So let's say we have 3 positives, doink, doink, doink. 3 black disks represent 3 positives. And then I have 2 negatives, doink, doink. Every positive and negative cancels each other out. So if I have a positive and a negative together, like this guy and this guy, they cancel each other out and make 0. We call that a 0 pair. So this guy here, doink, doink, would be another 0 pair. And we're left with just this one little guy on his own, and we would say that's positive 1. Okay, so that's what the integer model says. Every time you have a positive and a negative, they cancel each other out. Okay, let me just erase that. We'll look at another example. Let's say I had, 4 negatives, doink, 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 doink. And then I had 2 positives, doink, doink. Okay, so then our integer model says every time we have a positive and a negative together, they cancel each other out. So doink, 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 doink. And we're left with 2 negatives. That's really the basis of the integer model. Now, we're going to use this integer model to establish some patterns with integers. Occasionally, I'm going to get you to sketch out some questions with the integer model, but eventually we'll just use the integer model to establish some patterns, and I won't expect you to draw these out all the time, okay? It's just a way to demonstrate some patterns and some rules with integers. Let's use this idea to do some adding and subtracting of integers. I'm going to flip forward. Now today, we're going to start adding and subtracting some integers, and we're only going to focus on ones that have the same sign. So that means we're going to look at ones that have are both positive or both negative. Remember, a black integer disk is a positive, a clear integer disk or an unshaded one is a negative. We're going to do 3 groups of 3 questions. Each group of 3 is going to follow a similar pattern. And hopefully we're going to be able to establish a rule for what we do when 2 integers have the same sign. So the first question in each group of 3 I'm going to model out with the integer model. Now the first question says positive 4 combined with positive 8. So what I'm going to do is I'm going to make 4 positives, doink, 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 and I'm going to make 8 positives, doink, 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 doink. Now the integer model says every time you have a positive and a negative together, they cancel out. Well, there's nothing to cancel out here. So all I have are 4 positives combined with 8 positives. So that means my answer is 12 positives. I can write that as 12, or I can write it as positive 12. They both mean the same thing. So really, when you have a positive 4 and a positive 8, this is just like grade 3 math, right? Positive 12 plus positive 6, you combine them, you get positive 18, or just 18. And the reason we don't want to just stick with doing integer disks, because what if you get larger numbers? You've got to have some rules for this, right? And whenever you have 2 positives, you just add them up. Now this one I might need to line up the common decimals or the common place value spots and add up 9 and 6 is 15, carry the 1. 7 plus 5 is 12, plus 1 is 13, carry the 1. And 5. And these are both positive, 535. So whenever you have 2 positives, you add them up and your answer will be positive. Now let's see what happens when I have a couple negatives. I'm going to model this one out with integer disks. So we have 2 negatives, doink, doink, and we have 3 negatives, doink, doink, doink. Now the integer model says whenever you have a positive and a negative together, they cancel each other out. Once again here, we have nothing cancel each other out. It's all negatives. So all I do is count them up. 2, -2, and -3. Altogether, I have 5 negatives. Okay, so once again, if I have 2 integers that are the same sign, I just add them up. But this time, they were both negative, so I use the negative sign. This one here, I have 3 negatives and 4 negatives. That's going to combine to give 7 negatives. And with larger numbers, I might need to add them up. I have 677 negatives and 152 negatives. Since both integers are the same, I have to add them up. 9, 12 carry the 1, 8, and they're both negative, so the answer is negative. So just like the first 3, the signs were the same, so I added them. But this time, since they were both negative, the answer, after I added them up, was negative. Now let's look at the last group of 3. These are a little bit different, but the same all at once. Now the key thing to remember here is whatever sign is in front of the integer goes with the integer. So this is like -2. I draw a little force field around it to remind myself that the sign in front of the integer gets pulled in by that integer. And this one is -4. So -2 and -4. I'm going to model that out. Okay, I have 2 negatives, 2 clear integer disks. And I have 4 negatives. Doink, 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 doink. Once again, I have nothing that cancels out. There's no black and whites or positives and negatives that cancel out. So I'm left with 2 negatives plus 4 negatives is 6 negatives. And it's the exact same thing that was happening up here. In fact, every time when we have 2 integers that are the same, we add them up, or that have the same sign. So right here, remember, sign in front of the integer goes with the integer. That's -9. That's -9. I have 9 negatives and 9 negatives. Altogether, I have 18 negatives. And over here, I have -298. I have -167. Since both integers have the same sign, I add them up. And this one I'll have to do my column addition. 8 and 7 is 15, carry the 1. Those add up to 16, carry the 1. That adds up to 4. And since they're both negative, the answer is negative. So we've been able to develop a rule here. In every case on this page, when the signs were the same, we were adding up the integers. And we were using whatever sign they shared. So I'd like to write that rule down. I'm going to flip over here. When 2 integers have the same sign, I add them. And use the sign that they have in common. So if it's both positive, the answer is positive. If it's both negative, the answer is negative. The assignment you're going to do today, called Pictures and Germs, there's two pages to it. All the integers will be the same sign. They'll either all be positive or all be negative. So you'll have to use this rule when you do that assignment. Good luck with that. We'll correct it soon. Message me if you need help. That's all for now. Flexing Teacher Weber, out.